So hello everyone. Today we are going to solve question number 12 of Newton's laws of motion from the book H.C.VERMA. This is a very famous problem in which we are given that a man has fallen into a ditch of width d and his friends are pulling him out with the help of rope and fixed pulleys. So this is the figure of this question, and we are told to assume the force that is exerted by each friend to be equal, and we are given to prove something that as man moves up, the tension decreases. So this is the figure of the given question. This is simplified figure. This is the first friend, this is second friend, and this is the friend that has fallen. So basically the idea of this problem is that these friends are pulling him, and naturally you can see that the upward force on the man must be more than the downward force so that he gets up. So we will assume a simple equation of equilibrium here. We are using equilibrium so that both the forces are balanced, and in the end we'll say that the upward force is just equal to the downward force or the minimum upward force required. Okay, so let us draw the FVD. So this is the point M which is fallen, and let us assume the force that the friends are exerting, it is basically the tension. So let us assume it is T. And in the FVD there will be gravitational force. So let us assume the mass to be small m, and the downward force would be mg. So this is simple FVD of this. Now if we observe carefully, we have given some thing like depth d and height h. So if you observe carefully, height h is the distance between the pulley and the man. So when the man will go up, the h will obviously be decreasing. So h is variable in this question, and we have to basically do h equal to 0. Yeah, so this is other part of the problem, but to solve this we need equations, right? So we can't make equation right now here because we are not given angles, but we are given this thing h and d. So we will try to make out the angles. So distance from m and this wall would be d by 2 as it is symmetric. So we can make a triangle properly out of here. This is height h, this is a distance d by 2, and we can assume this angle to be theta, which is basically this angle. Okay, so we know Pythagoras theorem very well. So this side would be h square plus d square by 4, and if we say we take out sine theta from here, sine theta would be h divided by under root of h square plus d square by 4. Okay, so we know that t's horizontal components will get cancelled and only the vertical components will remain. So we can write f down is equals to mg, and f up is equals to, these two will get add up to, so 2t sine theta. So just as I have mentioned that we need to equate upward and downward forces, so here I can say 2t sine theta must be minimum equal to mg, and we know the value of sine theta, which I just h divided by under root h square plus d square by 4. So we can write it here 2t into h divided by under root of h square plus d square by 4. So remember, mg will be constant, his mass is not changing. Okay, so we can write it as mg, and we need to find out a relation, right? So we would take this h downwards, or maybe we write 2th is equals to mg into under root of h square plus d square by 4, and further we take like this. Okay, so t is equals to mg by 2h into under root of h square plus d square by 4. So for more clarity, we will do mg by 2 into, we would take h inside, so we would get h square by h square, that would be equal to 1, plus d square by 4h square. So now basically we can see that if h increases, d is constant, so this root would get increased, and if h increases, d square is constant, so this term would get decreased. Okay, I'm sorry, this would get decreased, so t would eventually get decreased. So if h increases, t decreases. So therefore we can say that t is inversely proportional to h, and this was the given condition to prove, so we have proved it. Hope you liked.